In this video, I'm going to go over a couple of examples of what we do when we're asked to multiply two scientific notations, or two expressions that are in scientific notation. Well, the commutative property is alive and well in these problems. And these are problems that some teachers go over, some teachers don't. I'm going over them with you just in case you get them in class or in case you want to discover what to do. So here we've got 4 times 10 to the 6th, all of that times 8 times 10 to the 3rd. Now this can be rewritten as 4 times 8 times 10 to the 6th times 10 to the 3rd. And you might wonder, what are you talking about? It's all multiplication here. That parentheses right next to that parentheses means we're multiplying these two numbers, and multiplication is commutative. So I could do 4 times 8 as much as I could do 10 to the 6th times 10 to the 3rd. So I join those terms together and see what I'm left with. Well, that leaves me with 32 times, same base, so we add the exponents. 6 plus 3 is 9. But that unfortunately is not an exponential form, right? It falls into this category right here. I shouldn't say exponential form, not in scientific notation, because our a value, the number we're multiplying by that power of 10, is more than 10. So we're going to need to make this now into a decimal, and that decimal is going to become 3.2. All I did is I moved the decimal point one place to the left. In doing that, I have made this number smaller by 1 power of 10, which means I need to make this power of 10 bigger by 1 to balance out the division we just did. Right? If I just made that go from 32 to 3.2, I divided by a power of 10, I can't just hand somebody $100 for something and then they say, sorry, that's only worth $1. We're going to divide that by 10 to the 2nd. What? Same thing here. We divided this by 10, so we multiply this by 10. And multiplying 10 to the 9th by 10, we'd be adding one more power to go from 9 to 10. That's awesome. Okay, on to this one. We're going to do something very similar here. We're going to rearrange our numbers. 5 times 7 times 10 to the negative 3 times 10 to the negative 2. And I thought I'd do this one so that you have some experience with a negative exponent. So we have 5 times 7 is 35 times, I'll do that with an X here instead of a dot notation like I did in the last one. 10 times 10, well, same bases. Exponents we add, negative 3 plus negative 2 is 10 to the negative 5. Now here I've got 35. Again, that does not fall into that criteria of having this number be greater than or equal to 1 but less than 10. So I need to move the decimal point one place to the left. We just shrunk that down by a power of 10. Well, if I shrunk this down by a power of 10, I've got to add a power of 10 to this. So I've got to add 1 to it, a power of 10. So that's going to be 10 to the negative 4th. And for the same reason as before, you can't just divide a number by 10 and expect it to be the same value unless you at the same time add a power of 10 to what you're multiplying by. That's it, folks. You've got gimmicks I'm sure that some of you have learned in class or some of you have learned from textbooks, and there are certainly many memorizations you could do. But the sooner we understand why things work and we let those support the reasons how we solve problems, the better we're going to be at math as a whole.